Okay, we're back, and in the last video we used code to find an optimal simple moving average numbers for a nominal value of buy or sell. I did do the same logic using a numeric classification value, and it turned out that there was pretty much no optimal moving average interval. So we're going to stick with the nominal classification of buy and sell to go on to our next video here, which is to predict future events. If you remember, in the last video we used a second ARF file to build a test data to speed things up. Well, we don't need to do any more testing. We're going to use all the data that we have that we can possibly use and load that back into the original ARF stream, and then use that test ARF file to create ARF data to let the classifier give us some type of prediction. This data will come from the data that we didn't use at the end of the period, which was days out less the length of the input. So the last 5 stock prices for SPY we didn't use. Well, we'll be able to use that data now to give us predictions 1, 2, 3, 4, and 5 days out. And the video will show you how we do that. Back into the development environment. Before we start with Eclipse, I just want to show you that I downloaded the data for expected values when we do these predictions. These here are the last 5 days from the CSV file with the close. 5 days out, or a whole week. These are the actual closes. And these here are the actions we should have taken based on the results from the prediction program that will be writing. Let's do the usual steps I do for creating a new program by taking the originating program and doing a save as. We'll just call it predict buy sell using random forest.java. Make sure we change the class name. Again, we're doing 5 days out. Creating the header that will be used twice, reading our SPY file. We still have the logic to load the dates, but as you'll see, we won't be using the dates anymore. But we'll just keep that in there. We don't need a results file anymore. We're going to kick out our results to the console. And let's change the fast interval, as our test showed the best fast was a 2. We'll keep the bracket in the for statement there just for grins and laughs. We build the fast array, fix the fast array because of the way ta-lib stores the data. And now let's change the slow interval, and the best slow interval we got was 18 with 2, a fast of 2. Keep the bracket, comment out the line. Now we start building the training and test data. Actually, the test data doesn't have to be built just yet, but calling the ta-lib slow moving average method, and we correct the array. This if statement here is going to get changed since we're going to load as much of the data as we can, which will be pretty much the length, the entire data less the number of days we're looking ahead. So we can take out that statement there because we're not doing a date test anymore. Obviously we can take out the else. But now we're going to need to add another quick loop using to store the test data, and that will contain everything from in the last 5 days in the array. But in this case, we simply change the initializer to the days length of the array less days ahead, and our end test will be ix is less than the length of the input array. If I could spell length correctly. The other thing we change is since we don't know what the buy sell indicator will be in the future, we use the missing value of question mark. And so the test data is built. We instantiate the training instances and load in the random forest classifier, build the classifier with the training instances, take our test data, instantiate it, and we still call evaluation and use the evaluate model method, but the evaluate model method returns to us a double array. We'll call it results. And these are the guesses that the evaluation is made. Now we're not using a CSV for that. We can get rid of that, get rid of that, and we're done. Well, we're not done because we want to see what the results are, right? So outside of those brackets, that's where we, this is where we instantiated the slow interval. This is one for, we instantiated the fast interval. We want to kick out results. And so we do that by going for results, double results of the results, and I can see now we have a problem with these brackets. The results object isn't available to us, so let's get rid of the brackets here. And that was at our instantiation, so we don't need that one. And we don't need that one. So results is no. Now what's going to happen is when the evaluate model runs, it's going to give us what it thinks should be the results. And since we passed it a array of strings as for our evaluation or classification, the results will be an index into that array of strings. So our results, array of strings in this case would be a buy or a sell. So if we get an index value of 0, it's a buy. If we get an index value of 1, it's a sell. So simply they say result equals 0, kick out buy. Otherwise, kick out sell. Pretty easy. Let's run it. And we get a sell and 4 buys. Let's copy that over and take a look how it did in our test here. Well, I got the first one right, got the second one wrong, the third one was questionable always, got the fourth one wrong, and I got the fifth one right. Okay, well now let's change the program to do the numeric classification. Let's do a save as. Predict, we'll call it predict price using, and we are using SMO regression, right? That looks like a pretty good name there. Do file save as, change our result to numeric. Change the result in our training data to the price 5 days ahead, and change their classifier. We don't need the random forest anymore. Change the classifier name in the evaluation clause. And this time it's simply going to kick out what it thinks should be the predicted price. So let's just do this. Kick out the price result. And we should be ready. And we're done. So let's take this and paste that into our spreadsheet. We'll call it predicted price. Let's convert that to well, let's just take a look. So the actual close was 263. This said it was going to be 270. That's way off. 266, 269, off by 3. This one's pretty close, 266. 56 to, that's off by $1.50. 264 to 267, that's off by 3. 264.98 to 264. This is only off by 50 cents, but you can see the predicted price didn't come out too well. So what do we do? Well, in the next video, I'm going to use Bollinger Bands to see if we can do this. That'll be fun. In the meantime, if you like what you see, press the like button down below. Oh, or even, why don't you subscribe while you're at it too?